Thank you, Steve. Steve said this is going to be a little different. I think the primary difference is that I can't tell all of the nasty stories I know, and I have to watch my language a little better than normal. But Larry and I have known each other a long time. We had a lot of fun writing this lecture series, so it's kind of nice. You could tell we're not spring chickens, okay? So the reason they really brought us back is it's like new to us. We've forgotten all this after 2 years. But we had a lot of fun writing the lecture. I first thought, man, we can't fill a day with construction problems. But after getting into it, it wasn't that hard. In fact, we cut a lot of material out as time went on. I do want you to have fun today. I want you to have a good time. I'll tell some stories to keep you awake, especially those of you that drove here early this morning. And as Steve said, we'll take questions at the end of each session. So that'll be the sequence. I generally like to find out to whom I'm talking first. I assume most of you are consulting structural engineers. Would you raise your hands if you're consulting structural engineers? How about any fabricators here? A couple. Any steel erectors? We can pick on the erectors then. Any architects? Thank you, sir, for being brave enough to raise your hand in this crowd. Usually when an architect raises his hand, they'll say, well, I'm also a structural engineer. Okay. So that I knew that, otherwise you wouldn't have raised your hands. Okay. All right. So Larry says that as designer, I've created all these problems. And then he, as the fabricator, has to fix them. So that's why it's the team. But we're going to discuss a multitude of items. I've got the topics listed here. And I won't read all of these, but first, what to do when first notified about a field problem. And then we get into footings and anchor rods, which is common throughout my experience on almost every project. There's some sort of problem with anchor rods. We get into spandrels and facade, and then a whole mess of miscellaneous topics that have come up from time to time, and I'll treat most of those. We get into connection fit-up, interference problems on the job site, how to reinforce connections if you have a connection that needs reinforcing, and then that's about where I end for the morning. And then Larry will get into columns, some of the problems he's seen with columns, beam lines or beams that are too short or too long, how to correct that. A host of problems related to camber, meaning too much camber, too little camber, deck bearing, all those items. A number of issues on shear studs, and then the list goes on and on. And Larry ends up with the welding topic here, and then I take over again after lunch, dealing with rooftop units, joists and joist reinforcing, several slides on crane buildings, which is my true love. And then Larry gets into specifications, how to create good ones to avoid problems, and into some connection design, and then we also take other questions. So that's the format. They were kind enough to put water down here with all the electrical stuff for me, so I'm very careful to how I pick that up. Okay, what to do when notified about a field problem. When I first started in business as a consultant, which was 1973, you got a problem from the field and someone would call you on the telephone. They'd say, take out a piece of paper and now draw a north arrow, and then you'd describe which grid line you were at, and then someone would try to describe the problem, and a couple of days later you might get photographs. Today it's much better. the contractor who's ever at the site can take plenty of digital photographs. You can have them instantly, and you can much more easily identify what you're dealing with. So that's a really good thing. But make sure when you get the information that you have as complete and accurate information as you can get. I can't tell you the number of times where I started off on trying to fix something and I really didn't have all the information, and then you start over again. So try to not go crazy right away, but think about the information you've received. Does it sound like it's complete? Have you really identified the problem? The next one is kind of hard for some people to swallow, and that's to act immediately to avoid delay charges. Now the problem as I see it, here I am the designer. There's a problem. I don't know if it's my mistake, error, or somebody else's. But I've come to learn it doesn't matter, okay? If it's a big enough problem, you'll be involved anyway, okay? But do something, take charge, act immediately, because the big cost on any of these problems relates to delay charges. You know, the erector's sitting out there with a crane that's costing him thousands of dollars a day, perhaps. And the more you sit around and do nothing, the larger the cost is going to be for an eventual fix. So I know it means dropping everything, and in today's world that's very hard, or these times. I assume things are good for everybody right now. But just jump into it, because it's the only way to get it done quickly and to avoid these delay charges. Then you, of course, try to determine the cause of the problem. What really caused this problem? Was it, because that relates to the fix. Was it something that in the design? Was it something in the fabrication? Was it something in the erection? Who knows? But try to determine the cause. And then ask yourself, is a fix really necessary? And as my friend Larry gave me this little quote, he says, if no money is spent on a fix, then there'll be no argument as to who pays. So think about it. Sometimes that's hard to swallow. I think the classic case is when an owner calls you up and says, can they take some bracing out of a building? And you don't want to admit that you didn't need the bracing. So you say, well, no, you can't do it. But I always tell them, yes, you can move it. Okay, don't take it out, but move it. And this kind of thing comes up from time to time with the owner might say, well, gosh, if I don't have to fix it, what was wrong with your design in the first place? And maybe nothing. So just think about that. Think about it seriously, because it can save time and money. The other thing is to think about the labor cost on a fix. Material's cheap, really cheap when it comes to fixing something. So you can get material out there. It costs almost nothing compared to the cost of the field labor. And the erector that may be doing the steel fix is not shy at all about charging big dollars for anything that he has to do in a fix. And I think you all know that I love erectors. It's one of the last macho jobs left in this country. Their concept, they know that if there's something wrong with the design or the fabrication, they're just going to put the steel up. They're going to Rube Goldberg it somehow, put it in place, and then they say, oh, there's a problem. Then they get paid to take it back down, and they get paid to put it up right. It happens on every job. And the primary reason is that they can't wait. They cannot wait for you and I as engineers to give them an answer. If they call it, they know it might take a day or 2 days, and they cannot afford to wait. So they just do something, and maybe it'll be right. So think about the labor costs. And discuss the paperwork. A lot of these should be handled like you do shop drawings and approvals, because depending on the project, the owner may want assurance. He may want a stamped letter or a stamped sketch or something that says, this is fine. It solves the problem structurally. So discuss the paperwork with whoever your client is, and if your client's an architect, they should be discussing it with whoever they're working for to make sure everybody's happy in the end. And finally, this is hard for a lot of engineers, but discuss your fee. Discuss your fee up front. I have never been embarrassed about talking about my money, because it's my money. And you know as well as I do that so many engineers, we have trouble getting paid, and part of it is because we're not upfront. If you do a bunch of things and say, well, we'll worry about it later, you may never see that money. So get a PO, get something, because even if they say, well, it's your problem, fine. If it's my problem, I still want to get paid for something I do that's not my problem. And we'll figure that all out in the end. Okay? And one of the things I've found is that when there is a problem, the erector's going to get paid. He's out there. He's at the job site. He's doing labor. Everybody sees that labor. The fabricator gets paid. He supplies new material, or he refabricates a beam. But the engineer, who's doing some calculations, doesn't really send anything to the job site. And they forget that. They forget that we spent $4,000 or $5,000. So in the end, when everything's sort of divvied up on who pays what, don't forget that you had money involved. So I just say, discuss it, bring it up. Worst they can do is say no, right? Many times I found that the erector or fabricator will propose a fix. And that fix may be one that he or she has used in the past. They may have seen a similar problem, and it may be perfectly adequate. But your job as the engineer is to make sure that it is adequate, that it is the right fix. The other thing that I think is very important is if, for example, the erector proposes a fix, listen very carefully. You may have a better idea, okay? But your better idea more than likely will cost more. Because the erector, if it's his idea, or it's the fabricator's idea, they're going to price it as they think it should be priced. And if it's somebody else's idea, I can almost guarantee it's going to cost more. So think about that. Listen to their ideas. Accept them if they're structurally sound. Okay? If yours is clearly much cheaper, you'll find out. But listen to the construction team. Okay. The biggest topic, of course, is footings and anchor rods. This is absolutely one of my favorite pictures. I took this picture in Boise, Idaho a number of years ago at a construction site where it was a beam and column job, and the erector put up a beam tying two columns together. These were about 45-foot high columns. The one you see laying on the ground here is a, can't remember, it might have been a 16-inch HSS. It was at least 12 by 12, I remember that. They went to lunch, a little 30-mile-an-hour wind came up. They had not tied one of the beams off on one of the columns. It slipped off, and it pulled the building down. Usually what happens, and those of you that have gone to the job site and seen an erection collapse, usually the anchor rods break. And the erector says, green concrete. You've all heard it probably. Green concrete, or there's something wrong with the anchor rods. I'm trying to say anchor rods. I just said anchor bolt one time, didn't I? You know why we say, AISC wants us to say anchor rods instead of anchor bolts? You know why? Because too many of us thought they were bolts. And we would specify a bolt that couldn't be long enough. Or we put the hole in the base plate thinking it was a bolt hole and not an anchor rod. And there's not enough clearance. So we'll talk about that later, but that's why we try to say anchor rod. Anyway, I was hired on this project by the fabricator to go look at it. And he had looked at this base plate, and the engineer had sized 4 3/4-inch round anchor rods on this 16 by 16, 45-foot high, and he felt they were too small. So he simply substituted 1.5-inch anchor rods on his own volition. Well, guess what? The anchor rods didn't break. The footing tipped over. And the ironic thing, I think it's ironic, every time there's a problem like this, we all get involved, we all get sued. That engineer was sued for designing too small of a footing. Now, he eventually got out of it, but, you know, after spending $30,000, $40,000 with lawyers and so on. Erectors forget that we design structures to be in their completed state. We don't design them for erection forces. We don't design them certainly for a beam falling off. But it's a classic picture. There were actually 3 or 4 footings just like this one that were all tipped over. What's the proper specification for anchor rods? ASTM F1554. It's not 307 anymore. It's F1554. There's 2 items of interest, what I call classification and product marking. And we're going to talk about those on the next couple of slides. But I do want to make the point before I forget it to consider the use of epoxy anchors on certain projects that maybe require a complex layout because you're going to get the epoxy anchors more likely in the right place than you are anchor rods. So we'll talk also about that later. The 1554 has 3 grades of anchor rods. You can get a 36 KSI rod, a 55, and a 105. Okay, so different strengths. And the product marking is if you have a 105 KSI anchor rod, it's supposed to be painted red on the end of the rod to identify it. Of course, that end will probably get buried in the concrete, but it's supposed to be red on the end. The 55 is supposed to be painted yellow, and the 36 blue. Now, often they don't paint the 36 because it's the lowest grade, and you don't need to paint it. So you won't find those painted very often. The other important thing to remember here is if you need a high-strength anchor rod, and let's say you want it to be weldable, you can ask for the 55 KSI rod to conform to S1, supplement S1, which makes it a weldable steel. Now, why would you want an anchor rod that could be welded? Because it'll help you in field fixes, that's why. I encourage you, unless you absolutely have to use high-strength steels, do not. Use the 36 KSI anchor rods that are weldable. It's much better to use bigger anchor rods and fewer of them than it is to use smaller, higher strength anchor rods. For example, if 4 anchor rods, it's a lot easier to get in the right spot than it is 8 or 10 or 12-inch anchor rods. You know, it just is much easier. So be aware of that. Try not to use the high-strength anchor rods, and I'll probably mention that several times. Remember now that OSHA has several requirements that we have to use 4 anchor rods in every column except for minor posts. That the anchor rods are to be designed for a 300-pound person, 18 inches eccentric from the column face. That takes nothing. You don't even have to think about it. If you've done the calculation once, you know that, 3/8-inch anchor rods will work. And I'm not saying you should ever use 3/8-inch anchor rods, but I think that OSHA requirement gave erectors a false sense of security about the stability of columns. But it does allow a person to go up and be 18 inches out without the anchor rods failing. Also remember that anchor rods cannot be repaired or replaced unless there has to be approval of the structural engineer of record, and we go on with other requirements that must satisfy OSHA. Okay, one of the first problems, anchor rods in the wrong position. This is a pretty drastic one. This was actually on one of our projects years ago. But you can see there was a fair amount of torching that went on and some slotting and to make those anchor rods fit. And here's one where you should evaluate. It may be, and it turned out on this job, we left the torch holes there. The only thing we did to stabilize this column was use some plate washers rather than regular washers. But we evaluated it and it was fine. So we left it alone. As I give talks, my mind wanders. It's not wandering quite so much this morning yet, but I was thinking about the number of times that this has happened in the past, and it's a big number. But I was also thinking of the number of times I did what I thought were crazy things to fix these problems, and maybe you've done them too. The two that come to mind, there was once a project in Poughkeepsie, New York, where a footing was poured and the anchor rods were poured roughly 12 feet from where they were supposed to be. It was a pretty big footing. I looked at it, it had a pier on it. I looked at it, hey, we can pick that sucker up with a crane and just move it over to the right spot. And we did. Nothing wrong with that. Put down a little slurry bed of concrete, which is probably better than what it was sitting on. Evaluated whether they could pick it up, without cracking the concrete, and just moved it. Many times I've heard people say, and I did it once, moving a footing a few inches with the bulldozer, just shoving it over. So you can do some nutty things, and they may be the best solution to the problem, rather than getting the dynamite out and blowing it out and starting over. I had that once. In fact, I'll tell you, it was a monster footing. It was in a steel mill. It was 30 foot by 40 foot by 8 foot deep. We put it in the wrong spot. They had to blow it out. No back charge. Great client. Larry gave me this picture. There's the template. Now, the interesting thing is here that the template was made wrong. The engineer showed center of template to anchor rod 8 inches. Whoever made the template thought it was 8 inches center to center of rods. So they did it. There's the old anchor rods cut out right here. They used the template correctly. But then new epoxy anchors had to be put in. And not just a few. This job had 1,300 anchor rods. So there was, I'm sure, a bit of a back charge on that one. So it happens. Anchor rods in the wrong position. What are we'll never solve, I'm convinced we're never going to solve that from not happening. Okay? We can try. But the solution, if it does happen, is evaluate the need for all the anchor rods. Maybe you don't need them all. Cut the rods off, use epoxy anchors. You might have to cut the base plate off and use, or cut the base plate and use the plate washers. You might have to fabricate a new base plate. Cut it off the column, make a new base plate that fits, re-weld it to the column. You may have to relocate the column on the base plate and adjust somewhere else. You might have to modify the column web or column flange. Or if the rods aren't too far out of position, it may be that you can bend them back into position, which may involve some chipping of the concrete. And I have a slide on that. Consider the use of epoxy anchors. Hilti has a HIT-TZ anchor that's relatively new that can be put in fairly nicely in adverse conditions. You know, holes don't have to be perfectly clean. The interesting thing is a Hilti 3/4 inch epoxy anchor has a strength of about 12,600 pounds, even if you just put it 5 1/4 inches deep into the concrete, which is almost equal to the 3/4 inch 36 KSI anchor rod, which has, what, 14,000. So you get pretty good strength. And quite often, you and I know, they're just there to be there. Once the building's up, you don't need them. Very important job, or some job you might want to consider proof testing or proof loading some of these anchor rods, 1 or 2 of them anyway. Like I say, I don't think we can prevent this from happening, but in your specs you should certainly have a qualified field engineer to lay out the anchor rods. I remember when we were writing this, Larry and I went round and round. I, as the engineer, said, oh, you must have a registered surveyor do this. That was what was in our specification. I said, no, you don't need a registered surveyor. You need a qualified person, because so often on the job site, you'll find that the qualified good surveyor knows more about checking things on a construction site than does a registered surveyor. So I compromised and said, no, I didn't compromise. I yielded to him and said, use a qualified field engineer. We say survey before column fabrication. I think that's baloney. The 2 fabricators that were here know it's baloney. You're already fabricating by the time the anchor rods are going in. But if you can, that would be a good idea. Use the AISC recommended hole sizes. Use symmetric patterns for the anchor rods. That is, use an 8x8 pattern or a 12x12, not a 6x8. That way you will get them at least oriented, you know, in the right direction. Although, depending on your column, you can have it put up the wrong way. So there's pluses and minuses. And then certainly the contractor should use steel templates or wood templates that are firmly, and I should underline firmly, fastened to the footing or pier so they don't move around when the thing's being poured to get them in the right place. These are the AISC anchor rod hole sizes. They're in the new 13th edition. They were in the last edition of the AISC LRFD manual. But you can see here that these are pretty big holes. If you have a 1-inch anchor rod, the recommended hole size is 1 13/16, okay? And the washer diameter is shown here. If you thought of these as bolts, this would have been a 1 1/16 inch hole, you see. It just wasn't going to fit. So those are the recommended hole sizes. And we said field survey the anchor rods, I mentioned that. The 4x4 you see sticking up there is there for just one reason, and that is to let the bulldoze operator know that there are anchor rods there. Okay, so he won't run over them. I don't particularly like that pattern. They're too close. There's too many anchor rods. I think it would have been much better to have 4 bigger anchor rods, but it's just a picture. This is also a picture that Larry Kloiber gave me, and this one, the base plate was refabricated, because you can see there's a god-awful amount of anchor rods there, and they didn't fit. So they refabricated a base plate and cut it off the column, and then now the column is refit to this stub that was down here. Lots of thread length on those too.